I'm currently working in TCS as a mainframe developer, and I want to switch from software industry to VLSI industry. I've done my BTech in 2021 in major of electrical and electronics engineering with a CGPA of 8 out of 10. I did my senior secondary from an senior secondary at 2017 with a percentage of 97, and my schooling in 2015 again with a percentage of 95%. And I have done my physical design training course from GPEDge last year April. It was a 4 months course till August it went. After that, I am looking for placements. So while doing my training, I did 4 projects. Mainly in that, 2 projects were from the 40 nanometer technology by Global Foundries, and the other 2 are from same Global Foundries as well, but with the 28 nanometer technologies. So the first for project with 14 nanometers was chip top. It is a cache design. It has total 4 macros and a clock with a frequency of 143 megahertz and around 32,000 standard cells. And it was from synthesis to routing. This the other one is JBI. It's also 14 nanometer. It's a block level implementation from synthesis to PV. It has around 86 macros with 2 clocks. One is 1 gigahertz and other one is 834 megahertz. Around with a leaf cell, leaf cell count of around 47,000. This After that, I did the 2 projects with 28 nanometers for my practice. One is DTMF, dual tone multiple frequencies. Uh, this has around 5 macros and 1 PLL, and it has total 3 clocks with 2 clocks around 200 megahertz and one is 500 megahertz. Leaf cell count is 38,000, around 38,000. And the last and this one is also block level implementation, and the final one is Falcon. Falcon
So,
is
okay.
yeah,
Okay, all these are done in your institute only.
yes, yes.
Okay. So just like we will start like mock interview just now. Okay.
Okay.
Uh, what are the inputs of PD?
Inputs of PD dot lib file, SDC, gate level netlist, UPF, scandef, def file, uh, .tlu plus. That's all I remember. Yeah,
Yeah, it's like technology file.
yeah. Dot text file. Yes, yeah.
Okay. Like, what are the information contains in a document file?
Dot lib file.
Yeah.
In dot lib file, we will have timing for each cell in each PVT process variation, process voltage and temperature. We will have timing information for all the cells in the dot lib file.
Okay. And like, what are the PVT corners?
PVT corners, slow, fast, typical. From around for 14 nanometers, from point 0.8 to 1.8, and temperature would be minus 40 degrees centigrade to 125 degrees centigrade. And from a process, it will be SS if it is low. If it is typical TT, or sometime in some other cases we will have like regular, and then we will have fast if it is fast one, FF.
No. Okay. What is the worst corner per setup?
Worst corner for setup, minus 40, sorry, SS, mm, 0.8, and minus 40 with RC worst.
Okay. Okay. Is RC corners for cells or nets?
For nets,
Um, Okay. Okay. Dot lib and dot left files or comes from
uh,
where it's
com-
come from.
dot lib comes from Foundry, and dot lib also comes from Foundry only.
Difference between left and left.
Left contains physical aspects like cell area and all that. Cell area, and lib file contains the logical aspects like time interval.
No, no, I'm asking like the left and the difference between left
Left
and
and
left.
def. Okay, in left we will have physical aspects of cells for all and or all the standard cells. In the def file we will have the physical aspects of our overall design, like floor plan, metal areas, and all that.
Okay. Um, how will you place the macros?
For placement of macros, we have some certain guidelines to follow. Like macros are placed in the corners of the core area with a center to place the standard cells. Pins should be faced inwards, I mean towards the center of the core area, and we should not leave any from like we should not leave any spaces in between the some like what can I say? We should use some leave some space for channel for routing purposes, and we should not have any blockage for standard cells or routing, and we should not restrict the routing for input IO ports and macro cells.
Why we only place the macros at on the edges of the core area, not at the center wall?
Uh, One thing is like macros are having more frequent communication with the IO ports, so they are placed near the IO ports. So that means around the edges of the core area. And other thing is if we place them in the center, standard cells will be spread around after placement, and it will be the routing will be huge from standard cells to macro, and again standard cells to mm, inputs, IO ports like that. So we prefer placing the macros around the edges only.
Okay. Uh, what are the checks you have to do before going to floor plan?
Check design, one to check for any unresolved nets or unresolved pins or ports. Excuse me, and timing checks. library checks whether we are having any cell, all the cells we need or not, or any black boxes we are having in the design. We will check that.
In check the design, what are the issues we will see?
First thing is unresolved pins or ports. Maybe some other block is connecting with our block, and it may be defined in the our block, but it's not having any logical connection. And some black boxes, like we are having some empty modules without any definition. This we will check. And fan outs we will check. um, Multiple multiple drivers for a pin or port.
Okay.
Yeah.
Um, and how you will fix timing in placement stage?
Timing in placement stage. Check design. uh, Checks pre routing, pre placement stage. By using the command we will check the design and check for timing also.
No, 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 I'm asking for how you will fix timing,
Okay,
fix
fixed timing. Okay,
placement,
we will pre placement stage.
placement stage.
In placement stage, one in placement stage, we can replace, not replace cells. We will just check by report timing. We will see where are the maximum timing violations are happening, and in that we will check what are the cells. If there are cells if it is used HVT cells instead of RVT cells, we will replace the cells. And we will manually adjust, place some standard cells near to the communication, whichever the block it is communicating. Whichever the standard cell. Thereby we can sometimes reduce timings setup. And
Only those are the fixes. No.
mm, yeah, that's all I can remember.
You have said that you will do manually, you will move the cells
Yeah,
manually.
manually move the some standard cells. Like if it is uh, it should communicate with the block, and it is placed far away from the block. We will try to manually move closer to that block so that it can communicate uh,
In
early.
projects, there will be like millions of cells. Then how you
Yes,
will
yes.
move all the manually? How will do all the move cells manually? There is no manually
Yes.
movement placement stage.
Okay.
Yeah.
Yeah.
So what is condition?
Conjunction means conjunction available tracks minus routed tracks. That means if the available tracks are more than the routed tracks, then routing tracks, then we can call it congestion. Like for example, if we need 10 cells in a particular area, if we got have more cells than that, then we can consider it as congestion.
How you, what are the fixes for condition?
For congestion, we can place have some soft placement blockages. Placement blockages, like a soft placement blockages. Sometimes we can also go for partial placement blockages to avoid congestion.
Okay. What are the goals of placement?
Goals of placement to place the standard cells with congestion driven and timing driven and in a legalized way in our design. Legalized way means to place all the standards in a standard cell rows.
What are the checks you will perform after placement?
After placement, we will check for
Checks after placement.
design violations. Design violations. Timing. We will check for timing, and we will check for core utilization.
Congestion.
Sorry, yeah, conditionals. Yes, condition and timing, design, core utilization.
So if the utilization jump is more, what we will do and what will be the reason?
Sometimes it might be design driven also. So if the designer needs has that jump in the core utilization, then it might be design. Sometimes if it's not like a design, then we have to check why it is placed, in which areas it is placed more standard cells. So we check. We will proceed in a better flow way. The last option would be like we will have to change the floor plan.
Okay. What are the goals of CTS?
CTS to have a minimum setup and hold violations with the minimum delays uh, to design a clock tree with minimum setup and hold violations and minimum delays.
Minimum which delays? Minimum delays.
Sorry, I couldn't hear the question.
Like you have said like you minimum delays, no? Which delays?
Minimum input delay, latency is nothing but input insertion delay. Yeah, insertion delay.
Yeah, you have to say that one.
Yes, insertion delay.
Interesting delay. Can you tell the stages of CTS?
CTS, first we will check the design. After that, we will provide NDRs. And after that, we will provide latency and fan out. Later, we will
What
give the
are
clock
NDR?
out. NDRs.
Okay, what are the NDR rules?
Non-default rules like we will have generally we will have non-default rules like double width double spacing, double width single spacing, like that we will provide some NDRs. And also we will we will provide the tool to use only clock buffers or clock inverters only for insertion of delays.
Why clock buffers only for clock? Why
In clock
you
buffers,
can't use normal buffer?
yes, clock buffers. We only use clock buffers because in clock buffers we will have equal on and I mean 50% of duty cycle for the in clock buffers and clock inverters. In normal buffers, we do not have that because for PMOS and NPMOS, we will have the flow of electrons difference. Like flow of electrons is two times faster than the flow of holes. So
If the minimum duty cycle is not maintained, what will happen?
Minimum duty cycle not it means like we will see more timing violations. Because of that, we need to. It will be like a huge. What can I say? We will have huge timing violations that we need to clear. So and the rise time and fall time of the cells will be different. So we cannot have that while using the clocks.
Okay. So what is the latency?
Latency is nothing but the insertion delay. The latency is the difference between the goodness, clock input for the one second. I'm just remembering. The latency is nothing but the difference between mm, yeah input. How can I say? I couldn't remember suddenly. One second. Sorry, I couldn't remember suddenly.
Okay, what is Q?
What is?
Q.
Sorry, I couldn't hear you.
Yeah. Skew. What is skew?
Skew. Skew. Skew is a nothing. Skew. A small left. One second.
Hello?
Yeah, it says 1 second. Yeah, just remembering that. I suddenly
Yeah,
forgot.
in CTS, what you have done?
In
CTS, what you have done?
yes, in CTS, yeah, I've just to check for check for the design. After that, I have this given some NDR rules. Then I have asked the tool to use only clock buffers and clock inverters. Then I have given a latency and maximum fan out for the clock, and I have given the clock out. Finally, after that, we have dumped the reports.
Mm, Come up with CTS.
Sorry, your voice is breaking.
Hello?
Yeah, yeah, yeah. Now I can. Yeah.
Yeah, sorry, some network issue.
Oh, yeah, sure.
Uh, yeah, what are the checks after CTS?
After CTS, we will check for the design and we will also check for core utilization because the tool has added the buffers, right? And we will check for power and timing, obviously, and also hold.
Only for latency, how will you minimize the latency?
For minimizing the latency, we can add some buffers to maintain the signal integrity if it is having the if it is a long driven net and in like short distances if the tool has placed any buffers we will remove them. mm, If it is placed like a HVT cell, we will try to place it with RVT cell. Sometimes we will also use LVT cell, but not some more in rare, very rare cases we will use LVT cells.
So what is the difference between HUT and RVT cells?
In HVT we will have high threshold voltage, more than the nominal voltage. Like for example, if we have 1 volt as a nominal voltage, plus 10% of that we will have as a HVT. 1.1 volt will be our HVT. RVT will be 1 volt, and LVT means low voltage. That means minus 10%. Around 0.9 volts will be our LVT for threshold voltages.
What about the power?
Power also uh, power consumption will be less for LVT cell, more for HVT, and but leakage will be more in LVT cells, and in the higher VT cells we will have lower leakage power. Yes.
So this is what all about today. So just improve the things. We will take your more or one more interview. Fine. Fine. Yeah. Okay. Fine. Thank you so much.
Yeah. Thank you, sir.